All right. Hey, what's up, everybody? Hutch here. And this is your Module 13 transformations. We're going to be talking about translations, reflections, rotations, dilations, as well as just some congruency, similarities, things like that. These are all 8th grade standards. It's setting you up to continue your knowledge base of geometry. You can take a look at your learning goals there on your own, as well as the 8th grade PSSA eligible content. These are the things that will be on the 8th grade PSSA. All right, so here is Module 13-1. Key concepts today is some new vocabulary here. So what are transformations? Obviously, maybe you've heard of the toy Transformers or the movie where they turn into from cars into these big robot things. So obviously, transformations are changing something. In this case, with geometry, it's moving something, okay? Moving a particular shape or a point or things like that on a coordinate grid. And so we're taking an original figure called a pre-image, okay? We know pre means before, and we are moving it to a new figure called the image, okay? And a transformation can be a slide, we can flip something, rotate it, or we can dilate it, or what's called resize it. Maybe you heard of dilating your eyes at the eye doctor. And so you can see here something like this. We have an original pre-image point of A, and it just moved, okay, to this location here. And that's called a slide, or what we call a translation, okay? And so when we translate that, you can see that it moved a certain way, okay? And the way that it moves is it moves left to right on the x-axis, and then it moves up and down on the y-axis. Okay. And so the way that we would think through that is we would go, okay, well, on the x-axis, I went to the right, and I went a little bit too far to the right. My hand's in the way. I went to the right this amount, and then I moved down, let's go ahead and switch colors, this amount to my new location. Okay. And so you just sort of document what you did moving in a positive or negative direction. And so I moved 1, 2, 3, 4, 5, 6 spaces. So this is a positive 6 to the right. And then how far did I move down? I moved down 1, 2, 3 to the 0, and then 4, 5, 6. So we moved down a negative 6. Okay, to our new location. And so notice this little symbol. This is an A with a little like apostrophe almost. And this is called A prime. Okay. If you move to another location, let's say here, you would have A and then double prime. Okay. And so that's how you show the moves and the order of the moves. Okay, so let's go ahead and head here. It says click the image below to watch the math short video, and we're going to fill in the blanks while watching the video. Okay, so what you're going to do is go ahead and tap it. It says open in Safari, and let's go ahead and take a look at this video to get a little bit of insight into translations, if it ever loads. There we go. Okay, we'll go ahead and hit play, see if there's anything else. That's a short 1-minute video.
Math Shorts.
Translation describes one way a geometric shape can move on a coordinate plane. When you translate a shape, it's like you make an exact copy of it and slide the copy to another spot. The shape stays the same. Here's how it works. Say we want to move this triangle to another location on a coordinate plane. First, we name the ordered pair for each of the shape's vertices. Then, to show where the shape is moving, we can use a mapping notation, like this, to show the translation. If we move positive 4 on the x-axis, then we know to move the shape 4 to the right. And if we use negative 2 on the y-axis, then we know to move the shape 2 down on the coordinate plane. Now we know which direction to slide the shape. Notice that the moved shape is congruent to the original, which means their corresponding angles and sides are the same. We use these little symbols to show what we've done to create this translation. So there you have it. When a geometric shape is moved on a coordinate plane, it's called translation.
All right, so let's go ahead and fill in these blanks here. When we're translating, Okay, so let's go ahead and highlight that word here, translations. Okay, when we're translating, it says you make an exact copy of it and then slide the copy to another spot, and the shape stays the same. Okay, they called it mapping notation, shows the translation. We're going to use a phrase that you can see down here called coordinate notation. Okay, and coordinate notation is going to be that same idea there, okay, as that mapping notation that they said. Okay, so we're going to go ahead and write coordinate notation. Okay, and we could put in parentheses here mapping. Okay, which is what they used. And so the final sentence here, the translated shape is in the blank size and shape as the original shape. Obviously, it is still the same size and shape as the original. So nothing changed with that. Okay, and that means that it's congruent, it's similar, has the same angle still, and nothing's changed in that sense. Okay, so translation, the easy way to remember this is a translation is just a slide. Nothing is changing. Okay, so go ahead and write that down. So let's go ahead and practice this. It's a pretty short lesson today to launch you into this concept. So it says graph the image of triangle JKL, okay, after a translation of 2 units to the right and 5 units down. Okay, write the coordinates of the image. Okay, so here's some notation here. Let's take a look at this. So I'm going to identify point J here, and I can see that it is, remember we always, with our ordered pairs, babies always learn to crawl before they learn to stand or fall for that matter. Okay, so crawling is left and right, standing and falling is up and down on the y-axis. So remember we have x and we have y. Okay, so please make those notes right there. So for J, we're at -3, 1, 2, 3, and then we're at +4, 1, 2, 3, 4. And that creates those ordered pairs, just as a reminder from back to probably 5th, 6th grade there. Okay, now where are we moving it? Well, it says we're moving 2 units to the right and 5 units down. Okay, so 2 units to the right, I'm going swoop, swoop. I'm counting the distance. Make sure you don't start at the dot or that point and say 1, 2. That's not accurate. We need to make a movement of 1, 2. So 2 units to the right is putting us right here. Okay, and this is going to be what we call, remember, J prime. Okay, so just a reminder, let's make that note. This is J prime. Okay, it's our new location. We have a pre-image and then an image. So let's go ahead and write what point J prime is. Okay, so we said 2 units to the right. Okay, so 2 units to the right is now -1. Okay, but then we need to move 5 units down. So this isn't really J prime in its final position because we need to go 2 over to the right and then 5 down. So 1, 2, 3, 4, 5. Okay, and so we end up right here for J prime. Okay, so you can see how that works. We end up in this position of -1 and then down to -1. Okay, so what happened with K? Well, K is going to do the same thing, right? 2 units to the right, 1, 2, 5 units down, 1, 2, 3, 4, 5, and we end up right here at this point. Okay, and so this is our K prime. And then let's go ahead and do L. L's moving 2 units to the right, 1, 2, 5 units down, 1, 2, 3, 4, 5, and you're just going to do that with your finger or your pencil. Okay, don't actually make the marks like that. And we end up with L prime right here. So every time you do this, I want you to label the points like that. Okay, now we can go ahead and connect them. You can use your great tool of locking in that line segment. Okay, just go anywhere, lock it in, and then connect it. Go again, straight line. Now I can move it around and lock it in to connect. So you can see we stayed the same shape, the same size. All we did was slide. So let's go ahead and record down our image coordinates here. So K prime is now 1, 2, 3 over and 1, 2 down. So positive 3 over, negative 2 down on Y. Okay. What's L on X? L is negative 2 on X, and now we fall 1, 2, 3, 4, negative 4 down. Okay, so this right here, we're just writing the coordinates of the image. Okay, and remember, image means the new image. So now let's go ahead and take a look at the next one. It says the graph of angle or triangle DEF has coordinates of D is 1, 1, E is 3, negative 2, and F is 4, 3. So let's go ahead and plot those points. So 1, 1, over 1, babies crawl, then stand or fall. Okay, so let's label it. This is point D. Then we have point E is 3, negative 2, over 3, down negative 2. Here's point E. And we have F is 4, 3. So crawl 4, 1, 2, 3, 4, and positive 3, 1, 2, 3. Okay. So at this point, we can see our triangle. Let's go ahead and connect the points. Oops, I forgot to label F. Okay. And so straight line first, lock it in, and connect. So we should have really nice straight stuff here. It's really nice to be able to use Notability for this feature. Okay, so there we go. This is what's called our pre-image, remember? So let's label this just to get practice with that. So this is our pre-image, okay? And now we're going to create our image. So it says graph the image and the pre-image after a translation of 5 units left and 3 units down. So let's go ahead and move this 5 units to the left and 3 down. Okay, so you just pick a point at a time. Doesn't matter what you want to do, whatever it is. I'm going to start with D, and I'm going to go 5 left, 3 down. So start at D and count on 1, 2, 3, 4, 5, 3 down, 1, 2, 3, and you should be right here. Okay, I'm going to go ahead and switch to a different color here just to have different points. Then let's do the F, paying attention to the movements. 5 left, 3 down, 1, 2, 3, 4, 5, 1, 2, 3. So there's that. And then we have E, 1, 2, 3, 4, 5, 1, 2, 3. And there we go. And we can connect our points here. We also want to label. So we have D prime, F prime, and E prime. Let's go ahead and make our connections. And there we go. Okay, and then just we'll double check, does it look the same? Yes. Okay, so all we did was translate. And so it says translate this using coordinates. And so what we can write for this one is we can actually say what we did to it. Okay, so I want to start getting you into this kind of notation. Okay, and this kind of notation is called that coordinate notation or the mapping notation. And what it's going to do is it's going to show what happened. And you can see an example of this right here. Okay, it's almost like a rule. Okay, what did you do to each of the points? So what I want you to do is I want you to just write the rule for what happened to X and Y. And so we're going to say X comma Y. And draw an arrow, and let's go ahead and say what we did to X and Y. Okay, so what did you do? Well, we took X, and what did we do to X? We went 5 units left. Okay, so that would be subtract 5. Okay, and then what did you do to Y? Tell us what we did to Y. We moved 3 units down, so that would be subtract 3. Okay, so this is what we did, okay, to these two things. The only thing we need to adjust is instead of putting the parentheses here, okay, we're going to go ahead and put a comma, okay? And so this whole thing is one ordered pair, okay? So you have X minus 5, comma, Y minus 3, okay? So there's one little piece that you want to remember. Okay, and there's some examples again for you to look at that template of how to show that coordinate notation, we're calling it. Okay, so let's go ahead down here and continue practicing this. So triangle XYZ, it's telling you it has vertices X of -1, -2, Y 6, -3, and Z 2, -5. Okay, write the rule using coordinates if the triangle is translated, and here's the important stuff, 2 units left, 1 unit up. Okay, and they want you to then write the coordinates of the image. So let's just write the coordinate rule first. Okay, so I'd like you to go back up to here. Okay, and when we talked about this, we talked about this just being the coordinate rule. So let's go ahead and write this here. So this is what we're doing to any of the coordinates. Okay, and so that type of thing is going to help us record the rule. Okay, so what is the coordinate rule? What are we doing to the X and the Y? So let's go ahead and record this. When we have an X and a Y, okay, coordinates, draw an arrow. What are we doing to them? Okay, we're taking the X and we're going 2 units left. So left is negative, comma, and we're taking our Y and we're going 1 unit up. So there'd be a +1. So that's the coordinate rule. If you follow that, then you will translate it correctly. So what are the new image's vertices? Okay, so we had a prime image. We're going to apply the rule and record what the new vertices are. So the first one, remember, X, okay, it was -1, -2. So now we're going to go like this. And essentially, do you see how we're sort of plugging in the X and the Y? Okay. This is just the variable. Okay, I want you to be aware of. I almost wish they didn't use X as the variable when we're talking about X's and Y's, but just be clear on that. It's sort of just like saying point A. Okay. And so I guess not really even the variable. This is really just the point label would be a better way to describe it. Okay. It has nothing to do with the x-axis. It's just a name for the point, okay, of the triangle. So we have point X. Its coordinates are -1, -2. So what are the new coordinates? The new coordinates for it are -1 -2, okay, comma, and then -2 + 1. Okay, so what would those be? That would put us at, if we did -1 - 2, what are our new coordinates? We have -1 - 2 would be -3, comma, -2 + 1 would be -2, + 1 is -1. Okay, so there's our new coordinates. Okay, let's go ahead and do the next one. Okay, so we need to just shift this out of the way a little bit. Okay, I'm going to shift and rotate if it'll let me. I don't know if it will. Yeah, there we go. Perfect. Cool. All right, let's go ahead and do the next one. Okay, the next one is point Y. What is the pre-image vertice? It's 6, -3. So let's go ahead and plug in the rule. So the rule is 6 - 2, okay, comma, and the y is -3 + 1. So what's the new ordered pairs? The new ordered pairs are 6 - 2 is 4, and -3 + 1, different sign subtract, is -2. Okay, and then let's go ahead and do the last one. The last one is vertice Z, or point Z, and it is 2, -5. Let's go ahead and plug in the rule. The rule is x - 2, so 2 - 2, comma, and let's look at the y now. It's -5 + 1. What's the new ordered pair? The new ordered pair would be 0, comma, -4. Okay, and so without having to graph it, we can just see what the new coordinates are of the new image. Okay, let's go ahead and try it now with seeing this. They want us to use coordinate notation to describe the translation. So we can go ahead and say what we're doing with X and what we're doing with Y. So let's just go ahead and analyze this. All you need to do is pick one of the points. So let's pick point A, okay? And we're going to go ahead and see what that movement is. And actually, point A isn't a good one to use. Do you know why? Point A isn't a great one that I would want to use because it's not really sitting on an X, okay? I mean, it technically is. It's -7, but I don't really want to count the space spots. I'd rather count one that's already nice and on a line, okay? Now, there's no way to fix that with the X and the Y both with this, but for this purpose, I'm just going to start with C and let's see where this goes, okay? So I'm going to go here and I'm going over one space, but you have to realize what a space is, okay? Because the intervals on our scale is by 2, okay? This movement is 2, 4, 6, okay? And then I have to get all the way over to the C. 2, 4, 6, 8, and then 9. Okay, so I'm going 9 in a positive direction. So I'm just going to make a note of what happened and say +9. And now I'm going down, but you'll notice that I'm in this like halfway point, okay, on the y-axis. So how far am I actually going down? Let's see. These are also going by 2s, okay, but I'm already at this halfway spot. So I'm going 1 here. And then maybe I'll just count by 1s. 1, 2, 3, 4, 5, 6, 7. Okay, so I went down -7. Okay, and there's my direct amounts that I went on the X and the amounts that I went on the Y. So let's go ahead and use coordinate notation, just describe the translation. What are we doing to X? So we're going to write XY. And we're going to go ahead and draw the arrow to say what's happening to XY. And we're going to say we start with XY and we take X and we add 9. Oops, we're going to use that comma, remember. And then what are we doing to Y? We're subtracting 7. Okay, so that's the coordinate notation to describe the translation. Okay, and you could have done that with any of the points. I just happened to choose C. Okay, all right, now let's go ahead and down to the apply, and that's it for today's lesson. This one is actually going back to something else, so let's see if you know what you're going to be doing here. Amelia's house is located on the map shown. She walks 3 units east, okay, so we got 3 units east, 2 units north to meet up with her friend. She then, I'm going to change colors, walks 1 unit west and 3 units north to get to school. If she were to walk a straight path from her house to school, what would be the distance? Write your answer as a simplified radical expression and round it to the nearest tenth. Okay, so let's go ahead and walk through this. Okay, she's starting at the house. Okay, and it says she walks 3 units east. So how many spots? 1, 2, 3 units east. So there we are there. And then she goes 2 units north. Okay. So I'm not going to have a line here. I'm just sort of tracking 1, 2, 3, and then 3 units north, 1, 2. Okay. So the first point isn't the 3 units east. The first point is at the ordered pair 3, 2. So really we're going to be moving over 3 and up 2. Or a better way of putting it would be X plus 3 and Y plus 2. Okay, so I'm going to go over 3, 1, 2, 3, and up 2, and here's my new point. Okay, so we sort of translated or slid the point to that location. Okay, and this one's going to be the friend. So we always want to make little notes, right? All right, now, she then walks 1 unit west. So we have a new move, okay? So now we're going x, and we're going west is left, minus 1. And what are we doing with a y? Remember, comma in between, 3 units north. So y is going plus 3. So here's my new sort of coordinate notation as I move. So let's go ahead and make that movement now. X minus 1, so 1 to the left, and up 3, 1, 2, 3. And here we are. Okay, that movement was left 1, 1, 2, 3, north 3. Okay, and this is school. So I got that labeled. If she were to walk a straight path from her house to school, what would be the distance? So now let's go ahead and draw these lines. Okay, and so we have a couple things going on here. We do have her, it says 3 units east, 2 units north to meet up with a friend. She then walks 1 unit west and 3 units north to get to school. Okay, so either way, we're making this path and asking this question of, if I just want to go from the house to school, how far would that be? Okay, and so at this point here, okay, I have to figure out this diagonal distance. Well, how the heck do I find diagonals? I know that we've talked before about we're not allowed to count diagonal distances, okay? But here's my thing I have to wonder. Can I make a right triangle out of this? Well, yeah, sure. We can make a right triangle. It doesn't matter about the other stuff. We just need to know this mystery distance. So here's my right triangle. And if I know a right triangle, can I use a specific theorem by a specific mathematician named Pythagoras? So I know this distance is 2. I can count straight line segments. 1, 2, 3, 1, 2, 3, 4, 5 units. Okay, and then I have a mystery unit. What should we label this? Probably C, right? Okay, so we've got side A, B, and C. Let's go ahead and figure out that distance from Amelia's house to school. Okay, so all that other friend nonsense, things like that, it was just helping us know where the new location was for school. So let's go ahead and set this up. We're going to use the Pythagorean theorem, a squared plus b squared, remember, equals c squared. Okay, separate my workspace. Go ahead and start substituting stuff in here. So what is A? We're choosing A to be 2 squared. B is 5 squared equals c squared. Okay, go ahead and solve. 2 times 2 is 4 plus 25 equals c squared. Continue down. 25, 26, 27, 28, 29. Equals c squared. How do I get c by itself? Square root of both sides. Cancels that out, and we're left with c equals. And here's what they say here. I'm going to explain this. Write your answer as a simplified radical expression. Okay, and what that means is we want to just keep it as small of a as a radical as we can. Okay, and so right now we have the square root of 29. And the reason we don't want to actually write what the square root of 29 is because guess what? It probably is an irrational number, right? Let's go ahead and look. Square root of 29 is, 5.385. And it continues forever. It doesn't stop, and it does not repeat, okay? And so we're actually going to leave it at the square root of 29 equals c so that we have the most accurate answer. And so we have that, but let's go ahead and leave it there, but also go ahead and write the rounded form. So it says write it as a simplified radical expression and rounded to the nearest tenth. So let's go ahead and take a peek at what that would be, rounded to the nearest tenth. We have c equals 5 point, and because of the 8, we have 5.4. And do we have... We don't have any units other than just units. Okay, so we're going to do units, and we could say approximately. Okay, all right, so we're going to leave things at that as those 2 answers, and that is good enough for this point. Let's go ahead and I do want to think about when we simplify radicals. This isn't something that we've talked about yet, but you can start to think, is there anything that you can multiply to get 29? And we know 6 times 4 is 24. And there's nothing to get to 29. And so we do want to think there are methods for simplifying radicals. This one is simplified as much as possible. So we're going to leave it as is. Okay. All right. So that is your lesson for today. If you have any questions, let me know.